Okay, here's a little explanation of our question, interpretation of velocity time data. So the question asks us to use a graph to calculate the acceleration of the object, and we're given velocity and time data. Using a piece of graph paper, I took a look at our data and saw that velocity, now let's see, why is this not working? Great. Okay. Sorry about that. So I took a look at our velocity data and saw that the smallest value was 4.3 and the largest value is 19.1. And I knew that there were about 75 squares here, so I chose to have each meter per second be 5 squares. I knew that there was about 100 squares this way, and the time went from about 0 to 8. And so I thought in going from 0 to 9 would work very well. And it did. Okay, so notice how the graph takes up most of the page. Notice how I didn't mess up with the spacings, and then the data are plotted here, 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 and here. Okay, this is then a best fit line that, notice how it doesn't have to go through all the points. This point almost looks like an outlier. See how these sort of follow a general trend, and then that one is a little too high. And then, so after drawing that line, I then chose 2 points exactly on the line. These are not data points, okay? So notice how they're far apart. And I just looked at the line and chose points that were sort of convenient for me in terms of reading the values. So the 8.45 I got from tracing down here, and the 18 I got from tracing over here. I picked that point. It is a point on the line. So same with this. I then found slope, not by counting squares, but by doing change in y over change in x. Okay, so that's our definition of slope. And in this case, our change in velocity per change in time is what we get when we find slope, which is by definition acceleration. So 18 minus 5.2 over 8.45 minus 1. And I ended up with something like this. The hint, 1.92 meters per second squared, is not correct. So when I made up this data, I thought, well, some kids might just take the last data point and the first data point and subtract to find slope. That's not correct. You should do a best fit line. Notice how a best fit line, let's see, can I draw a straight line? Probably not. But a best fit line through here would sort of not approximate the behavior of the points. Okay.